We're looking specifically at one-step equations. We're going to be relating a lot of what we do back to the blue ponds and the hands-on equations that we were using before. Hands-on equations, like I said, does a really good job of showing you a lot of things. However, negatives and subtraction kind of falls a little short. The first thing we're going to do is look at vocabulary inverse operation. Inverse operation is essentially just your opposite operation. You're always going to kind of undo a problem. All right, let's look at one example and then connect it to what we've done previously. All right, so in our first example here, I've got an x plus 3 equals 10. It's exactly like when we did our blue pond. So if I had a blue pond and then a number cube 3, and then on the other side I had a 10. What would be our legal move in that problem right there? Michael? Yeah, I could take away 3 from both sides. That's essentially what we're doing, only now we're going to be doing it algebraically. In order to get that blue pond by itself, I have to remove that 3. Because we're adding 3 to this side, we have to do the opposite of that. We have to subtract 3 from this side. Whatever we do to this side, we also do to this side. You can see how those two are related. So now I've got an x, I add 3, but then I take that 3 away, so those cancel out, and that leaves my blue pond on that side, and on the other side I've got 10 minus the 3, which leaves me with 7. Now the best part about algebra is you always know if you got the answer right, because you can always plug this back into your original equation. In the hands-on equations, it was called a check. So I'm saying that that's our 7. 7 plus 3 gives me 10, so I know that it's right. Let's look at another example. Let's say I've got y plus negative 5 equals 8. I'm going to solve this the exact same way. I'm going to put a line right down the equal sign. That way it shows me really clearly both sides of my scale. Now I want to get that y by itself. So I have to get rid of that negative 5. How do I get rid of that negative 5? There's actually 2 ways that we could do this. Somebody give me one way that we could get rid of a negative 5. Yeah. Sure. If I add a positive 5, won't they cancel? Yeah. Absolutely. What's another way to do this? Yeah, or I could subtract a negative 5. Because on this side I'm adding a negative 5. I could subtract a negative 5. Subtracting a negative 5 is the same as adding a positive 5, and I think that this makes a lot more sense. I have a negative 5 that I need to get rid of. So if I add a positive 5, those two are going to cancel out. But remember, whatever I do to this side, I also have to do to this side of my equation to keep it balanced. Those cancel. That leaves me with my y. And then on the other side, I've got 13. Now the best part about algebra is I can always check to see if that's right. You might want to use a calculator and do 13 plus negative 5 gives us 8, so we know we're right. Try this one on your own. X minus 1 equals negative 4. Now don't give me the answer. What's the first step? Kevin? Sure, I want to get that by itself, so I have to get rid of that minus 1. The opposite of a minus 1 is a plus 1. Whatever I do to this side, also have to do to this side. Now those cancel. X equals negative 4 plus 1 gives me negative 3. And you're thinking, Mr. Thompson, I got a different answer. Is mine right? What you have to do is plug that back into your original problem. Negative 3 minus 1 gives me negative 4. So I know it's right. Try this one on your own. Three equals a minus 10. What's my first move? Lena? Excellent. Everybody always says, well, I got to get rid of the 3 because they're used to just looking at the left-hand side. But this time, our variable's on this side. So we have to get rid of that minus 10. So we're going to have to add 10 to this side and then add 10 to this side. When we do that, those cancel. I've got a minus 10 plus a 10. That equals 0. That leaves me with 1a. On the other side, I've got a 3 plus a 10, which gives me 13. And you can always check your answer. 13 minus 10 gives you 3, so we know that that's right. (4x) equals negative 48. What's going to be your inverse operation here? Emily? Sure. Excellent. Yeah. Remember, inverse operation is your opposite operation. This is 4 times x. So you got to do the opposite of a times. Divide both sides by 4. When you do 4 divided by 4, what do you get? You get 1. Sure. You get 1x. So that's exactly what you want. You just want 1x over there. Then on the other side, I'm going to do negative 48 divided by 4, which you shouldn't need a calculator for. Gives you negative 12. And you can always check your answer. 4 times negative 12 gives you negative 48, so you know that's right. Your last example. Let's do n over 3 equals 5. Now that's written as a fraction, but what operation is that? It's division, yeah. It's n divided by 3 equals 5. A fraction is just a division problem. Numerator divided by denominator. So what am I going to do here? Toby, what do I do?
Subtract 3
Well, remember, I have to do the inverse, which is the opposite. So this is a divided by 3. So what's the opposite of a divided by 3?
multiply.
So I'm going to multiply by 3. And when I do that, 3 times 1/3, because it's 1 over 3, gives me 1n, which equals 3 times 5, which gives me 15. Here's another way to think of this problem. We just got done talking about proportions. If I wrote 5 as a fraction, I could just do 5 over 1, right? Does that look similar to proportions that we were solving like 3 weeks ago? If I multiply diagonally and divide, what do I get? It's the same problem. That's why the proportion works. So all of that is equivalent.